Hello Internet. Today you got what you asked for. Today we have not one, not two, not three. Wait, I can only count to three, so three it is. 3 AMD cards for your entertainment. Customer stated something along the lines they're broken, so let's take them apart one by one and see what's broken. I'll start with this prehistoric 470, some kind of mining edition card. Judging by the evenly spread thermal paste, this card had never been opened before. As always, we start with basic measurements where we get several kiloohms on 12 volt line, 215 ohms on 3.3 volt. That looks rather low, but I'm not familiar with this card, so I'll assume it's fine. This I believe is a 0.8 volt with 16 ohms. And this one is another 12 volt inductor with several kiloohms. And another 12 volt inductor here. On the back, VDDCI has 20 ohms, and the 5 volt rail shows 12K. There are also some fuses here, so let's check this one. And two more at the front. Now let's check the data lines at the front. And also on the back. Clock reference plus and minus are looking good. And the PAX reset is looking good. And now it's safe to plug in the card into the riser and check if we have any required voltages. Little over 0.9 volt on the 1.8 rail. 12 volt here. Little over 0.9 volt on the VDDCI. And the rest here are all VDDC with a little over 1 volt. 1.5 volt on the memory, and obviously 5 volt that started it all is present. Okay, let's plug this card into a computer and see if we get a picture. Looks like we have a picture, and according to Device Manager, we have an error code 43, which usually means memory problem. That's great. Let's run the memory test and see what we get. After usual struggling, I figured out how to use a T-server. Results finally came with no memory chips to blame. Okay, that's rather strange. Now let's have a look at the GPU Z. And the GPU Z says we have Samsung memory. If we look at the board, we do not have Samsung memory. Okay, straight to the tech power up to find the correct BIOS for this card, and I ran into a problem. I don't know who made this card, so I'll have to do my best to guess which BIOS would work. All I know at this point is that this card has 4 GB. If I Google what's on the card label, all I find is ASUS, so let's try ASUS BIOS first. To make flashing easier, I desoldered the BIOS chip and solder onto the flashing adapter. Flash new BIOS, desolder the chip from the adapter, solder it back onto the board, power it on, and I get no picture. Okay, let's look at the BIOS details. BIOS I used was made for a different memory brand. So I need to find the BIOS with the same memory brand and the same size, and repeat the process several times until we get it to work. Eventually, I got so tired of soldering this chip, I ended up soldering the adapter straight to the board. Being able to swap firmware quicker did not help, so I was forced to give up. And seller later clarified that it was some kind of Chinese mining card, so good luck with that. I hope lesson learned. Next on the list, Sapphire Nitro Plus RX 580 8GB. Customer stated, broken capacitor. So let's take it apart and see what's wrong. right before I finished taking it apart, I noticed this broken capacitor. Let's deal with that right now. It looks like the pads are still intact. I'll just move it around a little so it'll stay attached. This fuse here is good, and so are two more over there. 12 volt kiloohms, 3.3 volt 1.3K. This I believe is a 0.8 volt rail with 13 ohms. Very low resistance on VDDC. Kiloohms on these 12 volt inductors. 1.7K on 5 volt rail. 32 on memory, and 17 ohms on VDDCi. First data pair looking good. Second on the back looks good. Clock reference and the PEX reset all looking good. Next step is to power on the card and check for voltages. 0.9 volt on a 0.8 volt rail is present. Don't ask me why it's 0.9 and it's not 0.8. It never is. 12 volt comes from all over the place. 5 volt good. Memory 1.6. VDDCi 0.945. Core or the VDDC is 0.9, looking good. Okay, let's plug this card in and see if we get a picture. Card gave no picture, so let's run the command lspci and see if card is showing up. As you can tell, I do not see AMD device, and I hate that fact. Oh well, too bad. Okay, next let's check the logic for our PEX reset. On this card, it goes to this 5-leg chip. I want to see voltages on both of these pins on the top, and it looks like all is there. Next suspect is the BIOS. To find the BIOS chip, we simply look at the chip that has some kind of a paint mark, something like this one here. So let's flash this chip with the correct BIOS and see if that helps. Again, we make sure we have compatible memory, and in our case we have Micron, so let's download that BIOS and flash it. Followed by soldering it back on the board and running some commands to see if this time Linux will identify the card. And it looks like it does not. Okay, PEX reset work, BIOS works. The capacitor is in place. What do we do now? Let's get back to that capacitor. I measured the capacitor next to it, and we got roughly 230 nanofarads. Measuring this root capacitor revealed that it's not 230 nanofarads, and it needs to be replaced. Okay, let's replace this capacitor and see if that helps. And we have a picture. And Windows has loaded the drivers and it says it's working properly, so let's shut down, assemble the card, and run some tests. And a few minutes later in firmware showing good temperatures and low fan speed. I also ran Heaven for a few seconds to make sure we won't have any artifacts, which we don't. And as usual, the superposition to make sure the camera moves on smooth. And as of right now, this card is fixed. And that's it for this RX 580. Let's move on. Next on the list is Vega 64. 95% of the time this card comes with a dead core, so let's take it apart and see if that's the case. Multiple screws are missing, indicating someone had been here before. And there it is. Very big chip, but memory chips are missing. That, ladies and gentlemen, because memory is part of the GPU. That's why if memory dies, the entire GPU is also dead. Okay, let's take some measurements. 12 volt kilo ohms, 3.3, 2.7K. This one is a 12 volt, 0.8 volt rail with 18 ohms, 1.8 volt with 1.8K, 34 ohms here, 42 ohms there, and the rest of those around are the core. Data lines here looking good, as well as on the back, and clock reference and the PEX reset are looking good. I don't see any abnormal resistances, so let's power it on and see what it does. This time I had to send my lab power supply to just over 3 amps because this card is rather hungry. Okay, here we go. 12 volt present, 0.8 volt present, 1.8 volt is there, and 0.9 volt is there. Okay, let's plug this card into a computer and see if we get a picture. Windows is attempting to install drivers, and as soon as it does, I lose picture, giving me a false assumption that the card is crashing when drivers are installed. Next, I will boot this card as a secondary device, and according to the device manager, the card has no problems. So I ended up trying again, and it seems to work just fine. I think it's my HDMI splitter is not working properly, giving me false diagnostic. And this is why it is very important to have proper equipment doing these kinds of repairs. Because just a second ago I was going to call this card a dead core, but after confirming my junky HDMI splitter, the card was actually working. I'm not sure why owner said it wasn't, because as you can clearly see, it does. No artifacts, no crashes, no high temps, nothing. Everything works smooth as butter, and that only means one thing. This card is a no fix, no charge. And that is it for you today. I hope you guys learned something from this video, and I'll see you later. Goodbye.